All right. So yes, welcome everybody. It is our March virtual quality talk. Good to see you here. And as always, I'll do a quick shout out to my wonderful KWSQA board members who are instrumental in helping to keep all of our events and things running here at the KWSQA. And also thanking D2L for continuing to sort of sponsor us by letting us use their Zoom account for these events. We'd also like to acknowledge that the KWSQA head office is located on the Haldeman Tract. This is land that was promised to the Haudenosaunee people of the Six Nations of the Grand River. It's also within the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. We, as always, feel very privileged to be able to live and work and build our software quality community here in such a great region. Important reminder about the code of conduct. Code of conduct is the same for both virtual and in-person events. If you have any questions about this, feel free to reach out to us at the address listed on the screen. You can also read the full version and more details of the code of conduct on our website. Speaking of the website, some things you can do while you're visiting there. You can purchase a membership if you would like to support our organization or vote or be eligible to run in our election this year. So those are available again this year for just $20. What else? You can sign up to our mailing list so you can receive communications via email. You can learn more about our mentorship program, which has been recently launched, and the first few pairings have started already. So that's a great initiative that we like to offer in the community here. Other ways you can get involved, you could present at an event like this. So if you have a proposal for a quality talk, you can submit that through the website. We also periodically, not so much lately, but hopefully we will again soon, host an event that we call Testing Games. And that is a great way for local startups to get some feedback and testing from the great testing minds that we have here in our KWSQA community. Targeting Quality, our annual in-person conference. The planning is well underway at this point, and we'd just like to remind you of a few key things here. If you have a proposal for a presentation for the conference, we'd love to hear that too, but you kind of have to do that soon. We close the call for proposals in a couple of weeks. If you'd like to attend the conference, registration is open, and until this Friday is when you can get the absolute cheapest tickets, which we call super early bird. So if you're able to get things coordinated, it would be great if you can get your registration in this week. But if not, of course, it will continue to be available in the coming months. Your organization could also sponsor the conference, and if you want to learn more about that, feel free to check out the website or send us a note via email. Okay, last announcement. If you fill out the post-meeting survey that you'll receive after this presentation ends, you'll be entered in a draw to potentially win a $50 Amazon gift card. That's a small way that we hope to encourage you to share your feedback, because we love to read it and we really do take it to heart and try to act on the feedback and opinions of our community here. So thanks in advance if you can take a few minutes to fill that out. All right, so on to the good stuff. Today we have Rob joining us all the way from Utah, and he is going to walk us through some exercises and information about how you can scale the testing pyramid in TypeScript. And so I will turn it over to Rob at this point. Welcome, Rob.
Excellent. Let me start sharing my screen. Are you able to see that?
Yep, looks good to me.
Excellent. So here's, so I'm really excited. We get to talk about testing websites and all things TypeScript, which is really fun. As we start talking about testing, we're going to dig into lots of samples. integration testing, end-to-end testing, unit testing, component testing. It'll be really fun. Here's the part where I tell you, I am definitely going to post the slides on my site tonight. And I've chased similar speakers who have said that and never posted them, which is why my slides are online right now. I just posted a link in chat, but let's head over to robrich.org and go find them. So when we hit robrich.org, we'll click presentations. Here's scaling the testing pyramid in TypeScript. Here's the slides that are online, and also the code that's online up on GitHub. It is online right now. Achievement unlocked. Woo! So while we're here on robrich.org, thanks for the introduction. Let's click on About Me and learn about some of the things that I've done recently. I'm a developer advocate. I'm also a Microsoft MVP and Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Arizona, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp closer to you, find me on email or Twitter. Here's the links right here, or on Mastodon, and let's get a GiveCamp closer to you. Some of the other things that I've done, I've worked on a few books. I also got to work on the Gulp project in version 2 and version 3, and I know we've since moved on to Webpack, but it was really fun to dig into that open source project. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments on the air and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into scaling the testing pyramid in TypeScript. We talked about this guy. So taking a step back and take a look at testing in general. Now, why do we test? Well, we test because we want to validate the features of our application, but we also test to be able to document our code's intent. And if our tests are simple enough, they can be really great documentation, both for existing and for new users looking to get familiar with our code base. What assumptions did we make? Why did we make them? Let's take a look at the tests and be able to validate that. And then even more so, tests are about risk mitigation. If our business would rather prevent an outage rather than suffer an outage, tests can be a really great way to solve that. Now, if it's faster to just fix production than write a bunch of tests, then maybe we don't want to mitigate that risk. The risk isn't worth mitigating. But that's one of the big reasons that we write tests, is about mitigating risk for the business. So what types of tests might we write? Typically, when we look at tests, we're looking at unit tests, and our unit tests are really interesting at testing small pieces of functionality. But how do we validate that those functions work in concert? We'll probably do integration tests, which is probably a test from here down, where we test not only this thing, but the layers underneath, probably the data store, external services. We're testing, well, everything from here down. Now, we may not start at the user's experience. Maybe we're starting at the API tier and just validating all the microservices. And then we have end-to-end tests on top of that that really start clicking buttons through the user experience so that we can get a feel for it. Now, as we do these tests, we'll notice that the end-to-end tests are slower, so we'll probably do less of them. And unit tests are faster, so we probably want to do more of them. Let's fail fast. And so by writing more unit tests, we'll end up with a good suite of things that can tell us exactly what's wrong in a particular piece. And then we'll have a few smoke tests that will validate that everything functions together. So we end up with a testing pyramid like this, where our end-to-end tests are just a few at the top. Our integration tests, maybe we'll have some more, and then we'll have a whole lot of unit tests. Now, this is definitely the ideal, but we probably end up with something like this. I've worked on far too many projects where we do this, where we have a few unit tests, we have a medium amount of end-to-end tests, but then we have a whole lot of manual tests. And all of these manual tests are, well, really expensive to run. We're just paying people to push the button every time. Every commit that we do, hey, can you go run the whole suite of tests again? They may take 2 hours or 2 days or 2 weeks to be able to validate that our system functions. And I do another build in 5 minutes and we have to start over. Those manual tests can be really expensive. Could we do it differently? Well, yeah, let's come back to this testing pyramid and say, well, let's have a few end-to-end tests. Let's have a medium amount of integration tests where we're testing all of the boundaries between our systems, and a whole lot of unit tests. If we've validated that our system works in a very automated way, then the manual test can be about exploratory testing, about fuzz testing, about trying to do things that users may not need to do, rather than just validating the features that we expect to work anyway. That's why we have these automated tests. So we're building tests in a browser. How does this work differently when we have a thick client, a React or a Vue app, a progressive web app, a single page application, a PWA or a SPA? How is this testing methodology different here in this web world? Well, we still have unit tests where we're testing small pieces of functionality. So at this point, we're not really testing any user experience. We're just kind of running things into functions and validating that they work as expected. We might test this component. So I need to be able to mount this component and then start to interact with it. If I click a button in the component, does it trigger the events that I need? If I'm passing in specific props, does it render correctly? We might test that unit tests run in a particular browser. And that can be really helpful. Now that we have HTML5 and ES6, then that's a little bit less of a concern. But it is still a concern to say, well, is my progressive enhancement working as expected? So we're not running end-to-end tests in a particular browser, but we might want to run our unit tests in a browser. We could test an API. Maybe this is a REST API, GraphQL, a gRPC API. And the cool part here is that we don't need to involve a browser here. We're just firing requests at an endpoint and validating that the status codes work as expected, that the body is as we expect. We could also test from here down, end-to-end tests, where we're actually starting to interact with the user experience, clicking on buttons and validating that we can get to wherever we want. And there's lots more things that we can dig into, but here's the ones that we'll look at. So what tools might we use? Here's the slide that grew into this talk. I actually pulled this slide from another talk that I had written where somebody said, well, can you do a talk demoing all of these? And so that's exactly what we'll do today. We'll take a look at each of these types of tests, and we'll show an example of a test built that way. If I'm doing unit tests, I'm probably using Mocha with Chai, or I'm using Jest. Maybe I'm still using Jasmine. If I want to run those unit tests in a particular browser, Karma is a good suite for that. Now, Karma is a little bit older library and browsers have caught up, so maybe we won't do those today. If I want to do component tests, TestUtils is really great for every SPA framework, and I can use the variant for that SPA framework to be able to run some unit tests in that framework. That'll allow me to mount components. Maybe I choose to mock child components or render them, and then validate that my components behave as I expect. If I'm doing API tests, I could use Axios. Axios is probably the library that I'm using in my front end anyway. So let me just fire requests at my APIs and validate that they work as expected. And I can do end-to-end tests. Maybe I'm using Selenium today. We'll see Cypress in our demos today, but there are others as well. And what's really cool is as you grab these slides from robrich.org, you can click on each of these libraries to learn more about that particular library. Each of these blue links is a link that allows you to get more information. So let's dig into unit tests. Now, as we start comparing unit test frameworks, we have Jest or Jasmine that say expect.2b, as opposed to Chai, which we have to import. It's a separate library from Mocha, where we say expect.to.equal. For the most part, that's the only difference. So if you're happy with Mocha with Chai, or you're happy with Jest or Jasmine, you can stick with it and you will be completely successful there. Ultimately, do I want the dot between 2 and B, or do I want them to be separate, one function? Yeah, there's not a whole lot of difference. As we peel the onion, there's a little bit more difference between these libraries, but there really isn't a big deal here. Now we're going to do this in TypeScript. Why are we doing this in TypeScript? Because TypeScript really allows us to be able to check our types to validate that we're behaving as expected. Now, ultimately, TypeScript isn't necessary, but the world is kind of moving towards TypeScript. But when we start doing testing, and in particular mocking, then we need to be able to satisfy that TypeScript interface. So there's a little bit of intricacies here with mocking with TypeScript, and that's why our demos today will be in TypeScript rather than just in JavaScript. But if you want to just ignore all the type definitions and convert all the .ts to JS, then that will work just fine, and the principles still apply. And we're going to dig into mocking a little bit. Now, the difference between mocks and stubs and fakes is definitely interesting. I'm just going to call them all mocks today. When we're sitting around a beverage, let's definitely talk about the differences there. And it is kind of fun. The value of mocks is that we can swap out an expensive resource with one that we can more directly control. Let's test our error functionality. Now, to test our error functionality, we need that endpoint to return an error code. Well, I don't know, is Twilio down right now? Is Square down? I can't presume that my unit test can take Square down to be able to validate that my error handling works correctly. So I could mock out that Twilio API and be able to return a fake response that is an error response that I can then validate that my application behaves correctly. So we'll take expensive resources and replace them in our tests with resources that we can more directly control to be able to validate additional functionality. So that's a lot of libraries that we're going to take a look at today. And it's going to be really fun to be able to take a look at a unit test, a component test, an integration test, an end-to-end test, testing APIs. We'll get to see lots of really fun things today. So let's dig in. Now, the code is online right now here at our GitHub repository. And we do have all of the pieces of our app. So here's our app right here. I focused on an app that has enough complexity to it, but not so much that we're overwhelmed by the business logic. But in our app, we want to be able to do things like, well, not choose a square that's already been chosen. We want to make sure that if the game is over, we can't choose any other games. And once the game is over, we'll increment our leaderboard and be able to start new games. If we have a game that is in progress and we click a new game, it will ask us, do we want to give up? In this case, I'll say no. And it looks like I just found a bug in my application where it actually did start over. Cool. So that's our application. And we can see that the leaderboard actually reaches into an API that will be able to show us interesting things. So let's set that aside for a minute and build our hello world test. Now, it's always interesting to say time to first it. So let's create a new file, hello world.ts, and I will say it should pass, and then I'll pass in lambda here, and I can say assert true equals true. I could even give it a reason. I need to pull in assert, so let's do that. Import assert from assert. And now we've got a test. We can run this test. I've rigged it up in my package JSON to fire up Jest. So we can come here and we'll say npm test, and that will run our test. Now I am waking up my node instance. I'm also hosting a bunch of stuff on my machine. So it isn't super fast at this point, but we just wrote a test. And in a second, this test will go green. Excellent. Now that's a hello world test. How do we get from 0 to 1 tests? Exactly that. Now let's increment this a little bit more. We can wrap these in a describe block that will give us context. So in this case, I'll say these are the hello world tests. And now that I've got that group of tests, now I can put all of the tests that I have in this thing. Now I want to swap out assert for Jest, which I don't need to import. So now I'm going to say expect true dot to be true. And now that's a little bit more legible. I can kind of see that I've got my actual and my expected, and I can kind of delineate them. If we go back to our old one, I spent a long time once trying to swap between expect and assert, where my test kept failing. It said 7 should be 5. And I debugged my test and I said, well, I got 5 as well. And so what's wrong with my test runner? Well, I had gotten these things backwards. And so it actually got 7, but it should have been 5. So flipping over to this syntax is a little bit easier. Oh, and now it's going to put that in the way instead. Okay, so we've got expect true to be true. And now let's add a little bit of pattern around this. Now we've got an arrange act assert pattern, arrange act, that allows us to be able to test drive our tests a little bit. So in our act, we'll say actual equals true, and assert, we want expect expected to be, or expect actual to be expected. So what do we need to set up for that? Well, let's set const expected equals true. And yeah, we're not computing anything, but now we've kind of set up the expectation that we need. We've done the thing, and then we validated that it works as expected. So let's test this add function really quickly. We've got this add function that will return some numbers. Let's create a new test, add.ts. We might even name it test add.test.ts. Let's import add from /add. And if I remember right, it's actually exported, yep, not that way. So let's grab it this way. And now let's describe the add function. And here's our tests. Now we want to test something. Oh, too many parameters there. It should add 2 + 2. And let's create that test. And one of the things I really like to do here is to throw an exception. Not written yet. It would be really easy for us to accidentally not implement the body, run the test, it goes green, and we're like, and then not even realize that we didn't run our test. So the moment that I create the test, I'll create an exception. Okay. Arrange, act, assert. I want to act. I want to say const actual equals add x and y. Now I've talked about the behavior that I want to do. How do I want to assert it? Let's say expect actual to be expected. Now I know what I need to arrange. I need a const x equals 2, const y equals 2, and const expected equals 4. Now there is one problem with this test. What if my implementation was not addition, but multiplication? Well, 2 times 2 is also 4. I haven't validated that my function works as expected. So this test case is a little odd. Let's change this to 2 + 3. I know that 2 + 3 will behave differently if I'm multiplying or dividing. So now my test is a little bit more descriptive. Now we've got this test and we can say, let's run all the tests. And now we have 2 tests that are each going green. Perfect. So now that we've kind of documented that arrange act assert pattern, we've talked about how we can get started with jest. We might also want to say, well, JavaScript being JavaScript should add A and B. I could change this to A and this to B. And now I expect my add to be AB. And of course, it's going to be mad because my add function is using TypeScript that validates that these are numbers. But we can start to see the edge cases that we might want to explore. So that's our test app, and we've kind of now gotten our feet wet in testing. Let's come back to our real app. So here's our main app. We have an app.view that kicks off from our main.ts. And this app then will render the player titles. It'll loop through all the board tiles. It will render the game over and the leaderboard. And so this leaderboard is actually kind of interesting because the leaderboard only renders what we hand it in these props. It's not actually collecting the details. Back in our app.view, we can go feed the leaderboard the type of data that we need. Here's the startup data. Here's our game loop where we say, let's go check to see if we won. If we won, then let's update it. Is it a stalemate? If so, then let's do it. And we'll flip to the next turn. So every click, we'll go run our game loop and then flip to the next turn and do the thing. As we start up, we'll go grab the details out of our get scores method. So get scores actually comes from this data tier. Here's the scores. Now we're going to go hit that API to be able to go grab the current scores. And so here in our backend, here's our routes, here's our score API, and now here's that get scores method. Now we're getting our scores from Redis. This came from, in this case, a Docker Compose file that just says spin up a Redis, but we could point that at whatever Redis we needed. So I've stored that here in my app. And now I'm going to go call get scores. Now maybe Redis is blank. And so in the case of Redis being blank, I want to use a default score. Now here in my scores, this is where we actually implement this call to Redis. And so I passed this in just so that we could have some fun testing this kind of wacky app. But it may make more sense to make a singleton here and inject the Redis instance rather than passing it in. But yeah, let me go get the data from Redis, let me parse it as JSON and return it. So we've got this scores method that comes back into our front end, and we'll then take that score data and inject it into our component so that when we're rendering our component, we don't need to worry about trying to go get data from our API. That'll make testing this component a lot easier as well. Now, as we do things like check win, we're in our leaderboard component. Here, as we're checking our win, we'll just go reach into this check win method. Here's our check win method that just says, oh, nope. Here's our check win method. That just says, here's all of my conditions that might win. And so let me just go see if that's one of the conditions. I take in a list of squares. I go validate if my squares are a win. And if so, I'll return that win, and otherwise I'll return blank. So let's start out creating a unit test of this check win function. Now here I've just got a just unit test, and I just want to go pull in my check win function. I'll import some other interfaces that I've got it. And here's my board now. I've kind of said here is the scenario where X will win. Now, indeed, this is an array, and so I could choose to format it like this, but now my test is less legible. By formatting it like this, I now get to kind of visually see the board. That's great documentation in explaining how this function works. Okay, so we've got an X scenario, we've got an O scenario, we've got a stalemate scenario, we've got a blank board scenario, and each of these then will call this run test method where I'm doing my act and assert. In this case, I noticed that the act and assert were the same in every test, so duplicating it across all the tests didn't make sense. Now in tests, usually you want to lean away from being dry, but in this case, it was kind of interesting. I have my squares, or my spots here, my players, and I need to turn them into squares. So squares method that will just cast things in an interesting way. And now that I've got my squares, I can go check the win and validate that the actual is expected. So let's go validate no winner, stalemate, O is a winner, and an X is a winner. And now we have great unit tests in validating this function. We didn't need to mock anything. We didn't need to call any API. This was just purely hacking at a function to make sure it behaves as expected. And we specifically coded for legibility to document our methods. So we've got a unit test, that's great. Now let's test this component. Now the interesting thing about testing this component is we do need to mount this component. So let's pull in test utils. I'm using view in this case, and we will mount our leaderboard. Now, as part of that leaderboard, we only need to inject the props and then render it. So let's validate that it renders correctly in this test. So I'm going to inject a blank score list. And now if I get the text from that component, I just want it to say leaderboard and clear scores. It's not going to do all the things of saying, here's X and tie and 0 and O, because in this case, that component only renders these two pieces when given no data. So I was able to validate that my component now works as expected. Excellent. Now, what if I inject some content? I'm making sure that these scores are different so that I can validate each one works as expected. Let's mount it. Let's pass in that props list. And I now want that text to contain tie is 1. Now, if I had said all of the scores were 1, then maybe I'm rendering the wrong score in the wrong place, and I wouldn't be able to validate that. So I'm very specifically passing in different score data for each of these tests to be able to validate that I'm rendering this component correctly. So that was awesome. We were able to unit test a component. We could also look at other unit tests. Here's the board component that will do a whole lot more interesting things. We've got a whole bunch more unit tests here, checking stalemate, rendering icons. But let's flip over to our API and start testing our get score method. So we're here in our API, and here's our score method. Now, to be able to test this method, we'll need to look at some interesting things. We need a request object that has an app property that has a get method that returns this Redis object. Now, TypeScript says that it is of type Redis client. We're not actually using it for anything, but we do need to pass it in here to this get scores method. What I want to validate here is if Redis is blank, we'll use the default score. And if Redis is not blank, we'll use the Redis score. So let's come back to this unit test here where we're taking a look at the scores. Not that one, here. Oh, that's not it either. Oh, that is it. Nope. This is the one that we're looking at. We want a unit test of the scores. Now, in this case, we probably want to mock a bunch of things. Now, we want to mock a bunch of things because, well, I don't really care what this Redis object is. I don't care where you got get scores and default score. I just want to make sure that this function works as expected. So let's start mocking things. Well, I want to set up some default scores. So here's my scores. And I want to know that when I call get scores, this is the thing that I'll do. I move this to another little method because putting all of this stuff in the middle of my test would make my test kind of illegible. I moved it to this method. Let's use import mock, and we'll go grab the score data object and replace the get scores method so that it returns this particular thing, this score that I passed in. Now, this score data I got here, I imported this from that score class, and I made sure not to just import this as get data, because then I would only override my local one. Instead, I want to get the whole object from the store so that I can now override that, and I'll do that before I pull in my content under test so that it will make sure to swap out that method. Now it returns a sign-on stub. So here's the sign-on stub that it did. And now here in my unit test, I can say, okay, so now I've set that up so that when you call get scores, you will get this undefined method. Let's do a similar thing for the default scores. Here's the default score that I want to pass in. And here I'm going to do a similar thing, but now I'm overriding default. And I'm overriding default because here in the get scores, we say export default. And so that's the particular property that we want to override. Perfect. So now that we've got our scores set up, the next thing that we want to do is when we act, we're calling this get method and we're passing in a request and a response. We're not passing in the properties that we want. And so we can't exactly say const actual equals. We rather need to gin up these fake methods. So let's pull these methods in from TS AutoMock. By comparison, TS mock imports was how we mocked our imports. And this create mock will allow us to be able to mock out particular objects. We want to mock our request and response. And so here's our request and response. Let's start out by mocking a Redis client. Now, we don't need to do anything with Redis client. We're just passing this around. We just need something that makes TypeScript happy that this is a Redis client thing. Cool. So we just say create mock of that particular type, and it just works. Next, we want to create a mock of a request object. Now, this request object came from Express. And so now we're going to pass in a partial of request saying what functionality do we want to implement. In this case, we need an app property that has a get function that will return this Redis mock. Now, we don't care what that Redis mock is. We don't care what you ask for. We just want to make sure that this fake function returns that fake thing. We also need a response, and we need a response because here in this method, we're just calling res.json. We're not returning it. So because we're calling res.json, let's go set up our response with a JSON method. And in this case, we just want to call this callback saying, hey, here's what it is. You can now handle that, which is cool. So I'll pass in this callback into my thing, and I'll return this in case I chain it to say, I want to res.json.status. You know, if I did something like that, I would want to make sure that that still worked inside my test as well. Okay, so we've now created that request and response. Let's return the request and response. Here in our test, we'll now take a look at that request and response. We're passing in this body just to kind of grab this body in an interesting place. So we'll just kind of set that aside as the actual value. Now let's run that method. Running the method, we'll call into our function. It will go get our mock Redis. It'll go get our mock get scores and our mock default scores. It'll notice that this returned blank when we called it. And so we'll use our default scores. And that's the purpose of our test here. Let's go validate then that when we did that, the scores that we got were the default scores that we set up. Cool. So we were able to mock out some imports. We were also able to mock out some dependencies or some parameters and be able to validate that that is as expected. Let's do it again, but in this case, we're going to actually return data from Redis. We set this up in exactly the same way. And so now the resulting score that we got when we ran this method was the Redis scores, the one that we actually built. So now we've been able to validate that our get method runs as expected. We could do similar unit tests for our post and our delete to be able to validate that that system behaves as expected. So we've been able to do some unit tests that allow us to do mocks, which is really interesting. Next, let's take a look at our integration tests. Now here in the integration tests, I want to be able to test my API. Now I'm in our API class, so I'm actually firing up our application. Here in my app.ts, I actually have a function here, an init function that returns a promise. Now I want this init function to spin up my app the way I expect and then return that app. And I want that specifically so that I can start it in each of these integration tests rather than just fire it up once and presume that it'll work. And I'm going to specifically stop my application after I'm done. If ever you've run a bunch of tests and they all succeed and then the test framework times out, it may be because you've left your database connection open. So I'll very specifically look for that database connection and I'll quit it at the end of all tests. Okay, so now let's fire up these tests. I want to get my scores. So I'll use maybe Axios. In this case, I'm using Supertest. To be able to request that URL, I'll go get /API/score, and I expect that to return something. Now, I don't know what's in the Redis database, so I can't imply that, but I can say I did get a score back, and I'll just return it. Similar things, I'll do a post. I'm going to say, hey, this particular player won, so go increment that. Let's return that. And then these are actually both methods inside this one kind of bigger test. It's going to go run each of those API tests, but it's actually going to go grab those scores and compare them in this third test to say, well, X is the player that won, so it should increment by 1, and O and tie do not increment at all. So I was able to validate that my API functioned correctly. I tested from here down, and I was able to validate that behind the scenes, it could do interesting things. Now, I could have chosen to mock out Redis and be able to capture the things or seed Redis with particular data. But in this case, I was like, you know, Redis is doing just fine. I just want to validate that my endpoints behave as expected. So that's my integration test in my API from here down. I made sure to quit my database when I was done. And so now when we fire up our tests on the back end, we'll just run Jest, and Jest will run both our unit tests and our integration tests and validate that everything is as expected. So now let's do some API tests. Before they were open box tests where we could kind of see into it. Now we're going to fire at our API as if we didn't know how it worked, closed box testing. Now this does look really similar. We're going to go look for a base URL. We'll assume that it's already running. And then we'll go hit the API score method and we'll post to that method, incrementing a particular player's thing. And we'll go get those scores, validate that we incremented by 1 for X, but not for O. And that just runs this integration test, closed box testing, to be able to validate that our system works as expected. Now, in this case, we happen to use Axios to be able to validate that function. And that's because we use Axios in our front end as well. So it makes sense that we would use Axios for our API tests. Now, this validates that the API that the app depends on functions as expected. That's perfect. Next, let's start to do end-to-end tests. Now, here's where we're starting to interact with the app in a really interesting way. We're starting to click buttons. Now, I'm using Cypress for this. So we can say npm sci open, or we could do npx Cypress open, but I happen to rig it in my package JSON here. And so that Cypress test will actually then do some interesting things. I've got my test here. Here's my app test. And so I just want to go fire up my app. I'll visit my site so that now before each test launches, I know I've got my site running. And then I'll just go validate that my URL is as expected. Now, this is perfect. If ever you've refactored your website and you're like, well, I'm not sure which tests are hitting this page. Are they going to hit the new page? Is it going to work correctly? So I like a first test to just validate that the URL that I'm testing is the URL that I expect. Next, let's go validate that the title works. I love that Cypress, you can just go reach into it to go grab particular things. So let me go grab the H1 and validate that its text is this title. Now let's start to interact with it. Let me go click through particular things. I'll click through each cell. And I know that if I've done 0, 1, 2, so 0, 1, 2, 6, 5, 4, 3, 6, then I will get an X win. And so let's validate that X won. Excellent. Let's go validate that O wins. And so we're actually interacting with the interface. This could be perfect. Let's start at our home page, load up our shopping cart, look through our product catalog, add something to the cart, then get to the checkout spot, and we'll get to the point where we can start to interact with that thing. Now, we're probably not going to complete a purchase, but we'll validate that all of the pieces of our site work as expected. So it looks like Cypress didn't start up in time. Nope. npm run sci open. And now I can start to run these tests as if I was a user in a really interesting way. So let's fire up Cypress. And unlike Jest tests where they're completely headless and they'll just do the thing, these will actually open a browser and start to click through things. Now, the cool thing is I can interact with them in really elegant ways here, or I can, but I can also do that headless with a headless browser, as long as I've got a headless browser installed in my system. It looks like Cypress is not going to start in time. That's fine. So back here in my package JSON, we'll take a look at how we launch these tests. Now, here's our unit tests. So we'll just use view CLI service. we'll pass in a particular jest config that points it at this unit test folder. We'll test our API. Let's do a similar thing where we're running these API integration tests. And then we also have end-to-end tests where we're actually firing up the Cypress tests in headless mode and yeah, Webpack 4. And now we've got those suite of tests. Unit tests will run faster, API tests are medium, and end-to-end tests are the slowest. So then let's run our unit test first. Then we'll start our end-to-end test. So let's fire up our API server and on port 3000. Then let's run our API and end-to-end test. Our API and end-to-end test will run the API test first and then the end-to-end test. And so now we're able to run each of those tests, running the fastest ones first so that we can fail fast, and then ultimately kick over to the slower tests to be able to validate things. Now, I did in Cypress and in the other ones validate that I wanted to be able to harvest my test results using JUnit format. Now, JUnit format is just a XML format for test results, but the cool part then is I've pointed them all at the tests, the results folder. So here inside of our results, we'll now end up with XML files representing the results, both for the server and for the API. Now, the cool part here is for the Cypress tests, we also get videos showing how we click through each of these buttons. But let's rig that then together in a GitHub Actions build that will run all of our things. So let's go into our API. Let's build that and run our tests. Those will run faster because they're only unit and integration tests. But also I want to make sure I build before I start to use it in my production app. Let's npm install this. Yeah, there's a pull request open there. And then we'll build it and we'll run our tests, which will run our unit tests and our integration tests and our end-to-end tests. And we'll also launch Cypress before we go. So here's not Cypress, Redis. So here's Redis running inside of our build. And because we've now got this build in place, we can take a look at this result and we've got our code ready to go. We can run all of our build steps. It will run each of those pieces, but we also get a test report. Here's the results of all of our tests. And we can see that we've got green on our unit tests, our component tests, our integration tests, our mocks, and our end-to-end tests as well. So the cool part is that this code base is now available for us up on GitHub. And so you can start to dig into that right now. We definitely did go overboard in testing all the things, but we wrote a bunch of really cool tests, unit tests, component tests, integration tests. We mocked out dependencies, we mocked out imports, and we did end-to-end tests as well using Cypress. We ran that all with GitHub Actions to be able to launch that inside of our DevOps build. And arguably, we definitely went overboard on tests, but there's a bunch more tests that we could run as well. Performance tests, static analysis tests, exploratory tests, which are usually manual, maybe fuzz testing, security testing. That would be really fun if we wanted to take this farther. But looking at our testing pyramid, we can see how unit tests really use fake dependencies. Integration and end-to-end tests use real dependencies. And as we start looking at the libraries that we used in each place, for unit tests, we use Jest. As we started mocking things, we use TS mock imports to be able to mock our NPM modules, TS auto mock to mock our parameters into things. As we started getting into integration tests, we use Supertest or Axios. And for end-to-end tests, we use Cypress. This is how these tests fit into our testing pyramid. Taking a step back and looking at our purpose of testing, we did a lot to be able to validate that our system works as expected. And arguably, that's usually what we're thinking about when we're building tests. But we also focused on legibility. When we were building our test to validate the win strategy, we indented our thing to make it look like a board. When we were doing integration unit tests with mocks, we moved that mock setup into a named method so that we could focus then just on the business logic of our tests. And in particular, The purpose of testing is about risk mitigation. Now, in this case, a tic-tac-toe game, it may be easier just to fix the tic-tac-toe game than write all these tests. So maybe all of these tests weren't necessary. In a prototype, maybe it doesn't make sense to write unit tests because the purpose is to explore the space and validate the system really quickly. But in enterprise applications that are going to live for a long time, avoiding those outages can be really helpful. So risk mitigation is really important. This was a lot of fun to be able to show you all kinds of web tests in really interesting ways where we got to explore unit and integration and end-to-end tests. And we used TypeScript to be able to validate this in a really elegant way. It was fun to get to show you this. The slides and the code are online right now. If you're watching this on demand, find me on Twitter at Rob_Rich or on Mastodon, and let's continue the conversation. But for those of us here live in the call, what are your thoughts? What are your questions? What tests could we write in addition to this? What testing best practices have you found?
So many ways we could go with this discussion. Anybody have anything coming to mind?
Ooh, Tina points out a really good thing. I did right here. I pointed out fragile when I had made an assumption. So here, I'm assuming that Redis is running, and documenting that really nicely here will help us. If you get a failure right because Redis isn't running, this will probably help you know the cause of that. Thanks for pointing that out, Tina.
Yeah, that's just like a super handy technique that maybe seems obvious, but probably isn't, or easy to forget. But just like your future self, when you're trying to diagnose a test failure, will probably really appreciate stuff like this, where it's like, you know, maybe this could be the cause of a failure. Like just having that right in the code is such a good idea.
Excellent.
Sounds like people taking notes and bringing insights back to their teams. Yeah, like it was, for me, it was, you know, the main big concepts were definitely helpful and interesting, but also just all these little things, like just watching somebody else code is always super informative because you're like, oh, they do that like that. And like, it's just, you know, a combination of little things that can add up to big difference in how things go.
Exactly. And it is fun in this talk to be able to explore so many different types of tests because it's like, yeah, I've been writing unit tests forever, but how might I do an integration test? How might I mock things out? And that's where this code base up on GitHub can be really helpful. Clone this code base and poke at it and break it and fix it and really get comfortable with it, because I think those principles can really help you in your testing, if that makes sense, if you have the business need for it.
Yep. Yeah, that's kind of an interesting topic too. I mean, you could probably do a whole other presentation about it, but the idea that of like risk mitigation, you mentioned a couple times, like, you know, maybe sometimes you don't actually need to write like so many tests, and it's easier to just like fix a bug when you find one in production. And like, how do you know what situation you're in? Do you, like, we don't have much time, but do you have any quick like heuristics that you like to use to help yourself decide like what's a good amount of tests for my current situation?
Yeah, I skipped this slide for time, but exactly that. When the risk doesn't make sense, when mitigating the risk doesn't make sense, then writing the tests don't help. So, you know, we talk about, well, should I write this test? Should I write that test? Should I aim for 100% code coverage? I would argue that 100% code coverage probably tells you more that you're gaming your tests than that you're validating all of the scenarios. So I'll probably not do a unit test for my main app component, but I'll do an integration test for it. I might do a unit test for a particular piece of functionality that is particularly hairy. So we noticed in this code, this check win function is, well, a little bit weird. So being able to fire a bunch of requests that are simpler at this thing to validate that that works, that's a really interesting thing to validate. But maybe validating that my icons render correctly, that's not so much. So maybe I'll skip that unit test. taking a look at unit tests through the filter of business risk is really helpful to say, okay, this is the thing that failed recently. I'm going to write a whole lot of tests around that piece. Or this is business critical functionality. I'm going to do a whole lot in that. But could they get to the careers page? That's probably not as risky. I won't write any tests on that.
Yeah, and I think that's a good thing to keep in mind because there's, always the temptation of like, well, I could write tests for this and maybe they'd be really easy to write and maybe they'd make me feel good seeing all those green check marks all the time. But like it can sort of be a bit dangerous in a way because like, you could have 100 green check marks, but you haven't actually tested the critical things. And so green doesn't mean we're okay.
Yeah. There was one suite of tests that I was looking at where it occurred to me about halfway through trying to fix these tests that they weren't actually testing the code, they were testing the interface. And so they were firing a bunch of requests at their mock. And I'm like, you just tested nothing. You got a lot of green, but you didn't really validate any functionality.
Yep. The interesting question in the chat with a couple of aspects to it, but one of them is I think getting at like how do you sort of assess coverage at layers higher than unit tests when you can't really use handy measurement tools?
Yeah, that's a really good question. And code coverage is one of those that's easy to measure, but I would argue not so meaningful. If you have 10% code coverage or 30% code coverage, that tells you a lot. But if you have 90% code coverage or 100% code coverage, that probably doesn't tell you very much. So how do you validate this in integration tests, in end-to-end tests? I like to take a step back and look at the use cases of my software, the business scenarios. So I'll write an integration test that starts at my homepage, loads up the product catalog, adds something to my shopping cart, and gets to the checkout screen. That's really business critical for my application, and I want a test that does that. Probably a test that does that and a test that validates that, well, if my payment gateway returns an error, that I can still get to my shopping cart, maybe I can save my shopping cart. If my recommendation engine fails, that my product catalog still renders correctly, that's a good integration test. Have I met that threshold of coverage? Maybe not. I'm focusing on those business critical pieces. So how much of my app have I tested? Code coverage metrics are far too easy to measure, and we tend to lean on them far too much. I like to enumerate all the scenarios and then check them off once I've tested them thoroughly.
Yeah, or just talk through each of them like, okay, there's this scenario. How important is it? How much testing does it have? Does that balance feel okay? If yes, move on. Like, doesn't have to be even that they all get the same treatment or whatever. So yeah.
Yeah, exactly.
Lots of insights here. I think people are probably still processing, and it's great that you've got, the resources and the invitation to connect with you and that kind of thing for once people have maybe taken some of this back to their teams and tried it out. So really appreciate that as well. And great to have you here today. I know I thoroughly enjoyed this, and seems like everybody else did too. And yeah. Hope that you all have a great rest of the day. Thanks again, Rob.
Yeah, this was a lot of fun to present today. Thanks for joining us.
All right, see you later.